A very good morning to all my dear students. I welcome you all to this session of Chapter 4 Factors and Multiples. In the previous session, we had discussed about factors, properties of factors, and rules of divisibility. In this session, we will learn about the numbers. Basically, mathematics is all about numbers. Now the question arises, what are numbers? Now, let's go and explain. Well, a number is a mathematical tool which is used to count, measure, label, and calculate. All the numbers that you have studied so far are its examples. So 1, 2, 3, 4, 100, 10,000, 9,99,000. All these are examples of numbers. The numbers when started from 1 are called natural numbers. Now children, let's see types of natural numbers. They are even numbers, odd numbers, prime numbers, and composite numbers. Children, these are not the only types. Besides them, there are many more types of numbers which you will study in the higher classes. Now, first we will discuss about even numbers. What are even numbers? The numbers which can be paired are called even numbers. Paired means a group of two, just like a pair of socks. How many socks are there in one pair? It's 2. So we can say a number which can be paired or exactly divided by 2 is called an even number. It means that 2 is a factor of every even number. And what happens when 2 is a factor? If you will divide any number by its factor, then the remainder will always be 0. So the remainder of an even number when divided by 2 is always 0. And 0 itself is an even number. Now since here we are dividing by 2, so the rule of divisibility by 2 applies here. So all the numbers which have 0, 2, 4, 6 or 8 at their ones place are even numbers. For example, 38, 174, 3276. In all these numbers, we have an even digit in their ones place. So they all come under the category of even numbers. Odd numbers. Unlike even numbers, odd numbers cannot be paired. So they are not exactly divisible by 2. Now if we will divide an odd number by 2, then what will be the remainder? In such case, the remainder will always be 1. So all the numbers having 1, 3, 5, 7 or 9 in their ones place are odd numbers. For example, 25, 133, 2689. These all are examples of odd numbers. Next, coming to prime numbers. A number greater than 1 which has only 2 factors, 1 and the number itself, is called a prime number. It means that a prime number can be divided by 1 and itself only such that the remainder is 0. If you will divide a prime number other than 1 and itself, you will never get the remainder 0. So it is exactly divisible by 1 and itself only. For example, 2, 3, 5, 7, 11 and so on. These are the numbers which come only in their own table and no other table. Out of these, 2 is the smallest prime number and 2 is the only even prime number. No other even number is prime. 2 and 5 are the only prime numbers that end with 2 and 5. No other prime number has 2 or 5 in their ones place. And 3 is the smallest odd prime number. Other than 2, all other prime numbers are odd. Coming to twin primes. Two prime numbers whose difference is 2 are called twin primes. It means that you have to select any two prime numbers and you have to subtract them, and the difference should be 2. Only then they can be categorized as twin primes. For example, 3 and 5. When you subtract 3 from 5, the difference is 2. 5 and 7. 5 subtracted from 7 gives 2. 71 and 73. When you subtract 71 from 73, the difference is 2. All such pairs of prime numbers whose difference is 2 come under the category of twin primes. Next, coming to composite numbers. A number greater than 1 which has more than 2 factors is called a composite number. For example, 4, 6, 8, 9, 10, etc. Children, you have already found factors of numbers. All the numbers which have more than 2 factors come under the category of composite numbers. The smallest composite number is 4 because its factors are 1, 2 and 4. These are 3 in number. 4 has 3 factors, 1, 2 and 4, and is the smallest composite number. Now coming to prime factorization. Children, now you all know about factors in detail. Out of all the factors of a number, the prime ones, it means the factors which are prime, are called prime factors. So we can say that prime factorization is the decomposition of a composite number into a product of prime numbers. For example, if we take number 30, then factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 30. Out of these factors, the prime factors are 2, 3 and 5. So 30 is equal to 2 multiplied by 3 multiplied by 5. 2 3s are 6 and 6 into 5 is 30. So when we will multiply the prime factors, the product will be the number itself. We can also find prime factors using the division method. Here again the number 30 has been taken. First we will divide 30 by a prime number, that is 2. For finding prime factors, you have to divide the number only by prime numbers. You cannot take a composite number to divide that number. So here the smallest prime number is 2 and 30 is having 0 in its ones place, so it is divisible by 2. So firstly, dividing 30 by 2, the quotient is 15, which is written under 30. Now 15 has 5 in its one place, so it cannot be divided by 2. So the next prime number is 3. Now 15 is divisible by 3. In the table of 3, 15 comes at 5. So the quotient here is 5, which is written below 15. Now 5 is not divisible by 2 or 3, so the next prime number is 5, and 5 comes in the table of 5 at 1. You will keep dividing until the quotient is 1. Now you can match that the prime factorization done by division method is the same as the prime factors chosen out of all the factors. They are 2, 3 and 5, and when these three factors are multiplied, the product is 30. We can also find factors using the Factortree method. In Factortree method, you first need to recall the tables in which you have that number as product. Now 30 comes in the table of 2, then 3, then 5, then 6. You can use any of the tables. Here I have taken the table of 5. In the table of 5, 30 comes at 6. So we can say that 30 is the product of 5 and 6, or when 30 is divided by 5, the quotient is 6. Now here 5 is a prime number as it doesn't comes in any other table. But 6 is a composite number. It comes in the table of 2 as well as 3. So I will divide the number 6 by 2 and the quotient is 3. Now I have got 2 and 3, and both are prime numbers which cannot be further divided. So we can recollect here that the prime factors of 30 are 5, 2 and 3. Now children, let's solve some questions. Which of the following are prime numbers? For this, first you need to think how many factors do these numbers have. Now the first number here is 5. Now 5 comes only in its own table, so it has two factors, 1 and 5 itself, and no other factor. Next we come to 35. Now 35 is divisible by 5. It comes in the table of 5, so it will have more than 2 factors. Next is 41. Now 41 comes only in its own table, so it will have only 2 factors. Next we have 77. Now 77 is divisible by 7 and 11, so it will have more than 2 factors, so it cannot be a prime number. Next is 81. 81 comes in the table of 9, so it also cannot be a prime number. Next is 97. 97 doesn't comes in any other table except 97, so it is a prime number. So we can say that 5, 41 and 97 are prime numbers as they have only 2 factors. And 35, 77 and 81 are not prime numbers, or we can also say that they are composite numbers as they have more than 2 factors. Now list all the prime numbers between 10 and 20. Now again you need to think in the same manner. The numbers between 10 and 20 are 11, 12, 13, 14 and so on till 19. Now we will think about these numbers one by one, and when you will think, you will come to this conclusion that 11, 13, 17 and 19, these 4 numbers come only in their own table, so they are prime numbers, and 12, 14, 15, 16 and 18 come in the table of other numbers also, so they are non-prime, or we can say composite numbers. Next is name the smallest prime number. We have already discussed this, that the smallest prime number is 2. Next is the smallest composite number. Can you think of it? Yes, it's 4. Now write the greatest prime number between 21 and 27. First we will write all the numbers that come between 21 and 27. It is 22, 23, 24, 25 and 26. Now we will think about the factors. Now 22 is divisible by 2 and 11, so it cannot be a prime number. Now 23 come only in its own table, so it is a prime number. Next is 24. 24 is divisible by 2, 3, 4, 6 and so on, so it cannot be a prime number. Next is 25. 25 is divisible by 5, so it is also not a prime number. Next is 26. It's an even number, so it is divisible by 2. It means it is not a prime number. So the only number left is 23. So the greatest prime number between 21 and 27 is 23. Next we have write a pair of twin primes. As explained earlier, twin prime means the difference between two prime numbers is 2. So there are many such pairs. You can write any one of them. Here I have taken 3 and 5 because when you subtract 3 from 5, the difference is 2. Which of the following are prime factorization? Children, as I had explained, prime factorization means that all the factors should be prime and the product of those factors should be the number itself. Now here the first is 35. The factors are 5 and 7. 5 and 7 both are prime, and when we multiply them, the product is 35. So it means it is prime factorization. So it's a yes. Next we have 54. Here the factors are 2, 3 and 9. But 9 is not a prime number, so it cannot be the prime factorization. So it is no. Next we have 114 and the factors are 2, 3 and 19. All the three factors are prime. So let's multiply and check the product. 2 times 3 is 6 and 6 times 19 is 114. So product is also the same number. So it's a yes. Next we have 124. The prime factors are 2, 2 and 31. All the three numbers are prime, and when you multiply all three of them, the product is 124. So it's a yes. Next is 180. Here the factors are 2, 2, 3 and 15. Out of these, 15 is not a prime number, so it cannot be the prime factorization. So it is no. Now the last is 144 and the factors are 2, 2, 4, 3 and 3. Out of these, 4 is not a prime number, so it cannot be a prime factorization. So it's a no. Now write the prime factorization of 36. For writing the prime factorization, we can use any of the methods that were explained earlier. Here we will use all the three methods one by one. Now in the first method, first we will write down all the factors of 36 and then we will choose the prime ones. So for writing the factors, we will read tables in a sequence. Now first comes the table of 1. In the table of 1, 36 comes at 36. So we can write it either 1 multiplied by 36 or 36 multiplied by 1. Next comes the table of 2. In the table of 2, 36 comes at 18. So we can write it either as 2 multiplied by 18 or 18 multiplied by 2. Next comes the table of 3. In the table of 3, 36 comes at 12. So we can write it as 3 multiplied by 12. Next comes the table of 4. In the table of 4, 36 comes at 9. So we can write 4 multiplied by 9. Next comes the table of 5. But in the table of 5, we don't have 36. So we will leave it. Next comes the table of 6. In the table of 6, 36 comes at 6. So we can write 6 multiplied by 6. Now children, here you can see that 6 has repeated itself. Once the table starts repeating it, it means all the factors of that number are complete and we need not read the tables further. So the factors of 36 are 1, 2, 3, 4, 6, 9, 12, 18 and 36. Out of these, 2 and 3 are prime. But 36 is equal to 2 multiplied by 2 multiplied by 3 and multiplied by 3, because when 2 and 3 when multiplied will give 6 and the number is 36. So we need to multiply again by 6. So we will repeat the factors here. So prime factorization of 36 is 2 multiply 2 multiply 3 multiply 3. Now coming to the second method, Factortree method. Now in Factortree method, as explained earlier, we can use any of the tables. Now here I have used the table of 6. In the table of 6, 36 comes at 6. Now both the numbers are composite, so we again need to divide them. Now 6 comes in the table of 2 at 3, and the same I will use for the other 6 also. Now here I am left with 2, 3, 2, 3, and all these 4 numbers are prime, which cannot be divided further. So we can conclude that the prime factorization of 36 is 2 multiply 2 multiply 3 multiply by 3. Now next coming to the third method, which is the division method. Here we will divide the number only by prime numbers. We will not use any composite number to divide. So the number here is 36. Now it's an even number, so it is divisible by 2. So on dividing 36 by 2, the quotient is 18. Now 18 is again an even number, so again dividing 18 by 2 and the quotient is 9. Now 9 is not an even number, so it cannot be divided by 2. So now coming to next prime number, which is 3. Now 9 is divisible by 3 and the quotient comes 3. 3 is again divisible by 3 and the quotient comes 1. We will keep dividing unless and until we get 1 as the quotient. I hope that you have understood the concepts of even, odd, prime and composite numbers. Also, the prime factorization with the application of rules of divisibility, which will help you in enhancing your understanding of factors. Happy learning. Thank you.